Hello, folks. This video covers Chapter 7, Section 4, Part 1. So, two angle identities that are paired together typically are double and half angle. So, just to keep the videos a little bit shorter and tackle one thing at a time, we're just going to talk about double angle identities today. There are 5 of them, and we're going to derive them pretty quickly, and then I'm going to show you how you can use them. So, what I want to do is recall our sum and difference identities. So let's recall the sign sum and difference identity. So which is the sign of alpha plus or minus beta is equal to sine alpha cosine beta, sine alpha cosine beta plus minus cosine alpha sine beta. Okay, so if I know this identity exists, I want you to consider the sign of 2 theta. So that's a double angle, right? 2 times an angle theta. So I want to do is kind of expand this. So do you agree that sine of 2 theta is the same thing as the sine of theta plus theta, right? Because theta plus theta is 2 theta. Well, if you agree this is the same thing as the sine of theta plus theta, doesn't this look like a setup for the sine sum identity where alpha is theta and beta is theta? So essentially, I'm going to plug in theta everywhere I see alpha and beta in this identity. So I'm going to say the sine of theta plus theta is equal to the sine of theta cosine of theta plus cosine of theta sine theta. And then if I kind of rewrite this, like do almost, I guess, kind of factor it out or just group it to, kind of go backwards. So in the same thing here was theta plus theta is 2 theta. Well, I have sine cosine plus essentially sine cosine, just a different order, all of theta, which can be rewritten as 2 sine theta cosine theta. And this is as far as I can simplify it. So this implies that the sine of 2 theta can be written as 2 sine theta cosine theta. So this is going to be the first identity that you need to write on your orange reference sheet, what I've just boxed there for you. Sine of 2 theta equals 2 sine theta cosine theta. So there's the first double angle identity. Like I said, there are 5. Okay, so to get the second, I want us to recall the sum and difference identity for cosine. So if we have the cosine of alpha plus or minus beta, that identity says that cosine alpha cosine beta minus plus sine alpha sine beta. So if we recall that, then I want us to consider what is the cosine of 2 theta. Well, just as we did with sine, I can rewrite the cosine of 2 theta as just cosine of theta plus theta. And then if again theta and theta, if this one's just alpha and this one's beta. And guys, just remember again, these are variables. I know I feel like I'm talking Greek here with all these Greek variables, theta, alpha, beta, but those just stand for variables. Theta stands for angles, alpha stands for an unknown angle, beta stands for an unknown angle. They're just variables here. Okay, then if I follow my identity, I have cosine plus, right? On the left side, I have cosine of theta plus theta. So since it's a plus sign and this sign is on the top of this group of symbols, I'm going to follow the top sign over here, which is minus. So then I'm going to have the cosine of theta times the cosine of theta minus sine theta sine theta, which could be consolidated, right, as cosine squared theta minus sine squared theta, which implies that cosine of 2 theta is cosine squared theta minus sine squared theta, and that's your second identity. Now, it kind of looks like the Pythagorean identity, right? Pythagorean identity, in fact, we need to recall that one too, because I'm going to use it. If we recall the Pythagorean identity, it says that the sine squared theta plus cosine squared theta is equal to 1. If I manipulate that a couple of different ways and then I substitute in, I can have two more forms of the double angle identity for cosine. One of them being cosine of 2 theta could be rewritten as 2 cosine squared theta minus 1. The other one being cosine of 2 theta is equal to 1 minus 2 sine squared theta. So this is if you manipulate the Pythagorean identity, plug it into this first cosine double angle identity, then you get these two. So this is the third and the fourth double angle identity. And the last double angle identity we're going to use is going to be if we recall the tangent addition and subtraction identity. So the tangent of alpha plus or minus beta is equal to tangent of alpha plus or minus tangent of beta all over 1 minus or plus tangent alpha tangent beta. Okay, so that's just the addition and subtraction. Oh, where did that ink go? There it is. Weird. That's just the addition and subtraction identity. If I take that, then let's consider what is the tangent of 2 theta. Well, again, that's the same thing. I can write as the tangent of theta plus theta. And then if I use what I know about this addition identity, is I have of theta plus theta. So if I have alpha plus beta like that, I'm using the top symbol. So I'm going to use the top symbol in every group of symbols in the problem. So again, if my first theta is considered as alpha and this one's beta, essentially I'm plugging in theta everywhere, right? So then this could be rewritten as tangent of theta plus tangent of theta all over 1 minus tangent theta tangent theta. And then if I simplify this, then I get tangent plus tangent is 2 tangent theta over 1 minus tangent squared theta. So that's what the double angle formula or the double angle identity for tangent is. Tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. So that is the fifth and last double angle identity to go on your reference sheet under double angle identities. Okay, and then I'm going to do one example of each. So I'm going to say if, maybe I should write this out. Okay, so here's the example. If the sine of theta is equal to 2/3 and is in quadrant 1, I want you to find the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. So basically, I'm giving you one trig ratio, and you need to find the double angles of that sine and cosine and tangent. Okay, so it'll have a few different parts to it. So I'm looking for 3 answers. First thing I'm looking for is sine of 2 theta. So if I use my double angle identity for sine, we know that the sine of 2 theta, as we just learned, is 2 sine theta cosine theta. Well, here's the issue. I have sine, right? I know sine is 2/3, but in order for me to plug in this double angle identity, I need cosine, right? So then what I'm going to do is if I need cosine, I need to find what is an identity that relates sine and cosine. Well, what if we use our Pythagorean identity, which says sine squared theta plus cosine squared theta is equal to 1. If I know sine is 2/3, and I can plug that in here. So I'm going to do 2/3 squared plus cosine squared theta equals 1, and then I can solve for the cosine in order to plug it into my double angle formula. 2/3 squared is the same thing as 2/3 times 2/3, which is 4/9, plus cosine squared theta equals 1. If I subtract 4/9 from both sides, I get cosine squared theta is equal to 5/9. And then to get cosine by itself, I'm going to take the square root of both sides. And then I'm going to get the cosine of theta is equal to, when you take the square root, you better remember plus or minus the square root of 5/9, which the square root of 5/9 is the same thing as the square root of 5 over the square root of 9 is 3. Now, I'm talking about cosine. Remember, I am in quadrant 1, right? So in quadrant 1, everything is positive. So that's the key, is that's why we need to choose the positive, is because we are in quadrant 1 where everything is positive. So that means we're going to take away from this that the cosine of theta is equal to positive square root of 5 over 3. I'm going to hold on to that value because I'm going to plug it into my double angle formula and then progress. So if I have the sine of 2 theta, which is going to equal 2 times, I know the sine is 2/3, and I know cosine now is the square root of 5 over 3. And then if I use this 2 over here as over 1, then the rule for multiplication is to multiply straight across. So if we multiply all of our numerators together, that's going to be 2 times 2 times the square root of 5, which is 4 square roots of 5. And in the denominator is 1 times 3, which is just 9. And that's as far as I can go. 4 square roots of 5 over 9. So there's our first answer. Sine of 2 theta is 4 square roots of 5 over 9. Okay, next example. Well, this is the same example, so I guess I shouldn't rewrite that word. It's just the second part. We found the double angle for sine, but next we need to find what is the cosine of 2 theta. Now, you have choices, right? So the deal is that you can use any double angle for cosine, and it's kind of just your preference as to which one you want to use. I typically will use the one that's going to be cosine squared theta minus sine squared theta if I know both sine and cosine. Otherwise, you could use one of the other ones if you know just one or the other. It really doesn't matter though. You'll get down to your answer either way. Now, like I just said, I know both cosine and sine. So if I want to find the cosine of 2 theta, we know that the cosine is square root of 5 over 3 squared minus, we know the sine value was given to us in the problem is 2/3 squared. And that's it for substitution. And then all we have to do is simplify this. Now, when you simplify this, you got to be careful. Remember, something squared is just that thing times itself, right? So this is the square root of 5 over 3 times the square root of 5 over 3. And I know some of us are terrible with fractions, so I'm just going to write this one out to make sure we're kind of understanding that simple math. We're going to multiply fractions straight across. So numerator with numerator. In this first one, square root of 5 times square root of 5 is 5. 3 times 3 is 9. Minus, in the numerator, 2 times 2 is 4. In the denominator, 3 times 3 is 9. And then we've got 5/9 minus 4/9, which you better not use a calculator for that, which is just 1/9, and that's as far as we can go. So there's our second part. Cosine of 2 theta is equal to 1/9. Okay, the last part of the problem is finding the tangent of 2 theta, so the double angle for tangent. Well, if you recall, the tangent of 2 theta is written as 2, it's a weird 2. It is written as 2 tangent theta over 1 minus tangent squared theta. Now, it's got all tangents, and we haven't found that yet. So that's the next thing we need, is we need the tangent of theta. Now, you know sine and cosine. So using your quotient identity, the quotient identity implies that tangent of theta is equal to sine of theta over cosine of theta. And you know what those are. So let's do that. So that implies we know that the sine of theta is 2/3 over, we know the cosine is the square root of 5 over 3. Now, I have this giant stacked fraction here, so the thing to remember is that dividing by a fraction is the same thing as multiplying by that fraction's reciprocal. Okay, also known as keep, change, flip, if a teacher has ever mentioned that little riddle to you before. I don't really care for it, but that's exactly what you're doing, right? That means we're going to keep our first fraction. We're going to keep 2/3 the way it is. We're going to change our operation from division to multiplication, and we're going to multiply, or we're going to flip or reciprocate only that second fraction. So we're going to multiply by 3 over the square root of 5. Okay, when we multiply fractions, we're going to multiply straight across. Now, you also can realize here, since these are being multiplied, I've got 3 over 3, and that cancels. So that's going to equal 2 over the square root of 5, but we know that that's not rationalized, so we're going to multiply it by square root of 5 over square root of 5. And then again, when we multiply straight across, we've got 2 square roots of 5 over 5. So we're going to hang on to that. We know that the tangent of theta now is 2 square root of 5 over 5. So there's the tangent of theta, but we need what is the tangent of 2 theta. And to find that, we're going to use that identity that we discussed earlier. So I'm just going to substitute in to this identity. So I'm going to do 2 times the tangent of theta. So that's going to be 2 square root of 5 over 5 all over 1 minus tangent squared theta. So it's going to be 2 square root of 5 over 5 squared. Guys, you're going to notice that I use a huge division bar to separate the numerator and denominator. So because I have fractions within fractions, it's important that you do your best to separate the main numerator and denominator. That way you can simplify within those first. Okay, so like this 2 in the numerator is technically over 1. So then if I multiply just my numerator straight across, so that means I'm going to multiply just the numerator's numerator. 2 times 2 times square root of 5 will be 4 square roots of 5. In the denominator, 1 times 5 is 5. All divided by, I'm going to keep this 1 minus, and I'm going to go ahead and square this right here. Now squaring that, if you needed to write it out, it's 2 square roots of 5 over 5 times 2 square roots of 5 over 5. Now, I expect that some of you are going to do this in fewer steps, but I know some of us are kind of still grappling with the fractions, so I'm being sure to write out every single little algebraic step here. Okay, I'm going to leave my numerator alone for a second. 4 square roots of 5 over 5, all over 1 minus. When I multiply these two fractions here in red, I'm going to do all that numerator together and then all that denominator together. So 2 square roots of 5 times 2 square roots of 5. 2 times 2 is 4. Square root of 5 times square root of 5 is 5. And then 4 times 5 is 20. And the denominator 5 times 5 is 25. And this is equal to 4 square roots of 5 over 5 all over 1 minus 20 over 25 is going to be 5 over 25, which is the same thing as 1/5. And then we end up here with what we did in the last problem. We have a fraction over a fraction, which is the same thing as 4 square roots of 5 over 5. Instead of being divided by 1/5, we can multiply it by the reciprocal of 1/5, which is 5 over 1. And then we're going to multiply straight across. Well, again, I have 5 over 5, which is 1. And then I just have 4 square roots of 5 over 1, giving us our last answer, Tangent of 2 theta equals 4 square roots of 5.